Dear students, after studying this module, you shall be able to know about the characteristics of toxicological examination, the limitations and complications of any toxicological analysis, and the indications related to the general toxicological procedures. Chemical analysis is certainly one of the most significant aspects of forensic science. Almost every piece of evidence procedures additional information when analyzed by a chemical procedure. There are two main types of tests used to determine a poisonous substance. One is the presumptive test and the other one is the confirmatory test. The presumptive tests are less accurate and merely show that the suspected element may be present, whereas the confirmatory test provide an affirmative identification of the substance in query. Presumptive test or the color test is a chemical procedure in which the substance tested for is acted on by a reagent which causes a change in the reagent, thereby producing an apparent color or color transformation, means the color change. Color test may be used to determine the presence of specific compounds or a general class of compounds. The procedures are usually rapid and can be easily performed. The approach of color test have different mechanism in terms of the underlying scientific principles. They both serve a similar function in the field of toxicology, that of providing a relatively rapid and inexpensive indication of the presence or absence of a substance and an indication of the identity of a substance. The emphasis for color test is on the indication only. Such tests do not provide any confirmation of identity. The color test, also sometimes referred to as the chemical spot test, provide toxicologist and drug analyst with one of the first tools for the presumptive identification of drugs and poisons. These color tests are most usefully applied to pharmaceuticals and scene residues and to a lesser extent to biological fluids such as stomach contents, urine, etc. They are used to place the unknown into a specific class of compounds or to eliminate the categories or classes of compounds. These color tests remain popular for many reasons. They are simple to perform and no extensive training is required for this purpose. As such, they appeal in situations where laboratory facilities may be very limited, for example, in cases of the developing world. They can be performed in the field by police officers or technicians, require minimal reagents, are inexpensive and give immediate results that can be viewed by the naked eye. In many instances, color test can also be used as TLC location reagents applied by the process of spraying or dipping. Color test ranges from those that rely on the reactions with certain functional groups, those that are almost specific for a given group, through to those that give diagnostic colors with a wide range of compounds. Now we will study about the forensic significance. Color tests are particularly important in clinical toxicology, particularly when a patient is being treated in accident and emergency and the clinical symptoms may point towards some form of poisoning. In such situations, the clinician needs to know as quickly as possible what substance or substances are involved in order to initiate the treatment properly. Under these circumstances, the color test can provide an indication of compound class far more rapidly than the immunoassays and the chromatographic techniques such as GC, that is gas chromatography, and HPLC, that is high performance liquid chromatography. Examples of color tests that are particularly important in this respect include the Trinder's test for salicylates, the Fujiwara test for halogenated hydrocarbons, furfural test for carbamate pesticides, test for cholinesterase inhibitors, that is organophosphate pesticides, sodium diothionate test for paraquat and diquat pesticides, and various tests for paracetamol including the ferric chloride test and Folin Ciocalciu, Libermans and Nestler's test. The color tests are widely used by police authorities and customs to detect the drugs of abuse. Important tests includes the Marquis test for opiates and amphetamines, Mandolins test for amphetamines, Scott test for cocaine, and the Gitzit test for cannabis. The color tests have also been developed for gamma hydroxybutyric acid, that is GHB, and its precursor, that is the gamma butyroactone, that is GBL. Next is tests for the detection of poison. Under this, we will study first the range test. In this test, about 20 ml of concentrated hydrochloric acid and 100 ml of water are taken in a porcelain basin in which a bright copper foil of around 3 into 1/4 inches is placed with one of its end fixed on the edge of the basin in the form of a loop. It is then boiled for about half an hour to see if the copper basin and the acid are free from the metal that is to be tested. Here it can be arsenic also. If a stain on copper foil appears, the blank experiment is to be carried out again with fresh materials. If the blank is negative, the suspected material is then added and boiled for about an hour or more with random addition of water and acid to make up for the lost time of the evaporation. A shining steel grain stain appears in a few minutes which become thick slowly. The stained copper strip obtained by the range test is then washed cautiously with water, followed by alcohol and finally with ether so as to remove the adhering fat if the mattresses are biological materials specifically. The strip is dried by keeping it in between the filter paper sheets cut in small pieces of around 0.2 millimeters into 0.2 millimeters size and taken into the range tube. The tube is then heated slowly on the flame of a spirit lamp. The black deposit on the copper strip volatilizes and gets deposited on the cooler part of the tube. The tube is then cooled slowly and viewed under the microscope. Characteristic octahedral crystals of arsenious oxide are seen. Organic arsenicals do not respond if the organic matter is not destroyed. Some organic sulfur compounds produce black stains of copper sulfide also, and which may be removed by the process of oxidation. The concentration of hydrochloric acid should not be too low or too high. This test is generally used for rapid screening of arsenic, antimony and mercury. Next in line is the Gitzit test. The solution obtained from the wet digestion process is tested by this method. 1 ml of the solution is taken into a Gitzit apparatus, 2 pellets of pure zinc metal are put into it, and 5 ml of dilute sulfuric acid is poured over the contents. The evolved gas is purified by passing over lead acetate paper so as to absorb the hydrogen sulfide gas and is reacted finally with mercuric chloride test paper. A yellow stain on the paper indicates the presence of arsenic. Third one is the Marsh test. Electrolytic Marsh-Berzelius test is done over the conventional zinc sulfuric acid method for the evolution of nascent hydrogen, as these reagents are often contaminated with arsenic, etc. Scanning materials like burnt bones, hair and nail peelings containing minute traces of arsenic, and for testing the feeble traces of arsenic present as a natural constituent in tissues, the Marsh test appears to be the only reliable technique available. The test is performed in the solution obtained from the wet digestion process. The solution containing arsenic in the pentavalent state is reduced to the trivalent state by boiling with pyrogallol solution and sulfurated water. 1 ml of the test solution is then taken into a porcelain basin, mixed with 2 to 3 drops of 0.5% pyrogallol solution and 1 ml of saturated sulfurated water, that is water saturated with sulfur dioxide, and boiled for approximately 30 minutes. The pentavalent arsenic is then reduced to the trivalent state. A blank controlled test is run by taking the dilute sulfuric acid in the cathode and anode chambers of the so-called Marsh apparatus and by passing a current of approximately 4.5 milliampere at 6 volts for 30 minutes. There should be no stain on the Marsh tube at this stage. The test solution containing arsenic in the trivalent stage is then poured into the apparatus and the process is repeated for 30 minutes. A mirror of black metallic luster is observed at the cooler side of the Marsh tube if present, that is if arsenic is present. To confirm that the mirror deposited in the Marsh tube is only due to arsenic, both the ends of the tubes are sealed after replacing hydrogen with air. The tube is then heated slowly on the flame of a spirit lamp by keeping the narrower portion of the tube cooler. The mirror disappears and the octahedral crystals of arsenous trioxide gets deposited on the cooler, narrower end of the tube, which is then identified under the high power of the microscope. Fourth test is the copper sulphate pyridine test. In this test, 1 ml of the extract is added to a dilute solution of copper sulphate, to which a few drops of pyridine have been previously added. A lilac blue precipitate is formed confirming the presence of cyanate. This is soluble in chloroform with the production of a sapphire blue solution. Fifth test is the Prussian blue test. In this test, take 5 ml of a freshly prepared 10% solution of ferrous sulphate in freshly boiled and cooled water is added to 2 ml of the extract. A greenish precipitate is formed. The hydrochloric acid is added dropwise to dissolve the precipitate. A blue coloration or precipitate, sometimes precipitate is formed on keeping, indicates the presence of cyanide. Next is fusion test. 1 drop of fusion reagent, that is prepared by dissolving 0.015 grams of fusion in 100 ml of water, is placed in a spot plate. 1 drop of the neutral solution of extract is added. The magenta color of the reagent is discharged, indicating the presence of sulfides. Next is the Zwickers test. In Zwickers test, the residue of extract is taken up in chloroform. To 1 ml of the chloroform extract, 2 to 3 drops of 0.5 milliliters of 5% pyridine is Chloroform is added and then shaken. The color of the chloroform layer becomes purple, and then 1 drop of glacial acetic acid is added to it. If the color of the chloroform layer changes from purple to weak blue, the presence of non-thiobarbiturates is indicated. If the chloroform layer becomes green after adding pyridine in chloroform, the presence of thiobarbiturates is indicated. This green color changes to light green on the addition of acetic acid. Next is Dile-Kopiani test. For the preparation of reagent, let us take reagent 1, that is the cobalt acetate solution. In the solution, 1 gram of cobalt acetate, that is tetrahydrate, is dissolved in 100 ml of absolute alcohol, followed by the addition of 0.2 milliliters of acetic acid. For reagent 2, that is the isopropylamine solution, 5 ml of isopropylamine is mixed with 100 ml of methanol. Then we have 2 test procedures. Under method 1, we have a small amount of the extracted material that is placed onto a spot plate. 3 to 4 drops of cobalt acetate solution and 3 to 4 drops of isopropylamine solution are added. The appearance of a purple or blue-violet color indicates the presence of barbiturate. In method 2, the residue of the extract of the sample is taken in 1 ml of chloroform. To a portion of the chloroform extract of the sample, 2 drops of freshly prepared 1% cobalt acetate in methanol is added, followed by 1% lithium hydroxide in methanol dropwise. A blue ring at the junction indicates the presence of barbiturates. Next is Mcnallys test. To the residue of the extract of biological materials, a few drops of acetone and 1 to 2 ml of water are added. 2 drops of 0.5% copper sulphate solution and 10% acetic acid is added, followed by a pinch of solid sodium nitrite. It is then shaken and heated gradually to boiling and maintained in the boiling condition for a few minutes. A red color is formed if salicylates and salicylic acid are present. Next in line is the Libermans test. Alkaline distillate is evaporated to dryness over a small flame in a porcelain dish and then cooled. A pinch of sodium nitrate is added. Thereafter, concentrated sulfuric acid is added. On mixing carefully, blue or green coloration is observed. It turns to red on addition of water and which turns to green if made alkaline by sodium hydroxide or ammonia solution. Blue-red color indicates the presence of phenol, while the violet color indicates presence of resorcinol. Green color shows the presence of alpha naphthol and beta naphthol. Brown to black coloration indicates or shows the presence of cresols and para-aminophenol. Next is Mandolins test. To the brucine-free residue, 1 drop of Mandolins reagent, that is 1% solution of ammonium vanadate in concentrated sulfuric acid is added. A deep violet blue or deep purple color appears, which finally changes to yellow on long standing, indicative of the presence of strychnine. Then we have Gerards test. 1 to 2 ml of 2% of mercury chloride solution and 50% of alcohol is added to a portion of residue of the extract. A red color develops immediately. Hyoscyamine produces a yellow color which becomes red on burning, while hyoscine does not produce any change of color. Next is Gonsbergs test. A few drops of Gonsbergs reagent, that is prepared by dissolving 2 gram of fluoroglucinol and 1 gram of vanillin in 100 ml of 95% alcohol is taken in a porcelain dish and evaporated to dryness over a small flame and then cooled down. A glass rod together with the material to be tested is added to the dried reagent and warmed gently. A purplish red color develops in the presence of free hydrochloric acid. Last one is the ammonium molybdate test. To 2 ml of extract, ammonium molybdate and nitric acid are added in substantial surplus or in substantial amount, you can also say. A yellow crystalline precipitate of ammonium arsenomolybdate is obtained on boiling. That is, distinction from the arsenides can be made which give no precipitate, and from the phosphates which yield a precipitate in the cold or upon gentle warming. The precipitate is insoluble in nitric acid but dissolves in ammonia solution and in solutions of caustic alkalis. Now dear students, let us summarize this module. There are two main types of tests used to determine a poisonous substance. That is, one is the presumptive test and the other one is the confirmatory test. Presumptive tests are less accurate and merely show that the suspected element may be present, whereas the confirmatory tests provide an affirmative identification of the substance in query or in question. The color tests are the screening test in the general method of analysis of toxicants. The positive finding is a presumptive indication for any of the poisons necessitating the confirmed identification. However, these tests are very important. Color tests are sometimes referred to as the chemical spot test also, providing the toxicologist and drug analyst with one of the first tools for the presumptive identification of drugs and poisons. Color tests are most usefully applied to pharmaceuticals and to scene residues, and to a lesser extent to the biological fluids also, such as stomach contents, urine, etc. They are used to place down the unknown into a specific class of compounds or to eliminate the categories of classes of compounds. The color tests range from those that rely on reactions with certain functional groups, those that are almost specific for a given group, and to those that give the diagnostic colors from a wide range of compounds.